Hello, everyone, and welcome to another wonderful presentation today at Adoptium. Today, we're going to be discussing the new tooling that's been created for the Temurin build repository. And this tooling is referred to as the Build Auto Triage tooling. Now, this presentation has been advertised as the Build Triage Accelerator, and that's for a very deliberate reason. It's because despite the name, Build Auto Triage only automates a portion of the triage. It makes sure the information that you need is where you need it, when you need it, nice and efficiently in one place. But then you have to go and take it and run with the ball and take it straight to the end zone. So you have to raise the issues and actually look at the problems and so forth. It doesn't do everything for you. It won't tie your shoelaces. So that was the summary for those who just wanted to know what it is. For those who'd like to know a little bit more, I'm now going to go into it in a bit more detail, show you a couple of examples, and then we'll take questions. The script itself is located in the Adoptium/Temurin-build repository. The current version of the script will take a list of JDK major versions, and it will return to you a list of all the failed builds that it located within those major versions. It checks to make sure that we're building on every platform we should for every version. It's sensitive to head versions, so sometimes in the pipelines, head builds lose the version number. So the pipeline will have the version on it, but the actual build jobs won't, and it handles that in a clever way. And it also makes sure that, did I say that we're making sure that we're building on every platform we should, and then we're not building on every platform we shouldn't. So it just makes sure that the pipeline is healthy from beginning to end, and we don't lose anything midway through. Okay, here's how it works. We have a Git action, which you can see. The Git action runs on Mondays. There's an optional additional bit that you can put into the GitHub action that will make it run every time you push. We decided not to include that in the official version because that also triggers when you're working on other things. And we didn't want to fill people's local repositories, their personal repositories, with issues containing GitHub actions. So we have the GitHub action here. The GitHub action runs the script, as you can see here, run build auto triage. And it's not expanding. Okay, whatever. Anyway, build auto triage runs. It gets the necessary information from TRSS. And
Adam, it says you need to sign in to view the logs, so maybe that's the reason you're not being able to expand it.
Sign in to view logs? That's weird.
Oh,
right. Yes, I see. Sorry, I copied these links over from my main browser into this separate window so we can make sure I'm only showing what I intend to show. I'm not going to sign in right now. We don't need to see the log output. Short version, it just goes through the different, it goes through the latest automated pipeline for each JDK version you've asked it to interrogate. So if I say, go and fetch me the latest pipeline for 8U, 11U, 17U, 21U, and 22 head, then it will rush off and get that information from TRSS, making sure we're building all the builds we should, and then identifying all of the failed builds before we progress to the next stage. The next stage is the second phase that is described in the, let me move your faces over to the other side, in the auto triage regexes. And what you see is what you get, really. It's a list of different regular expressions that match against lines of error output within the build itself. It helps you to identify the specific issue that you're seeing. It means you don't have to go Control-Fing your way through the output in order to try and figure out what's going on. Sometimes it can be a bit hit and miss, but as all the outputs that I have personally inspected, it's been 100% accurate. So it knows what a segmentation error looks like, it knows what an out-of-memory error looks like, and that allows you to quickly identify the issues in question and get these things raised and get these things fixed. Now, as you can see here, every single regular expression comes with some metadata. So SIGSEG V is the pattern it's matching against. The metadata in this case is just segmentation error. P is for predictability, as in whether we believe that this issue could have been predicted in advance and prevented. 0 means it could have been, 1 means probably not. Segmentation errors in this case are typically caused by upstream issues, so we don't consider it something that we could have predicted and prevented in advance. The S, let me just remind myself, there we go, failure source. The S is primarily for filtering further downstream, and that's whether or not an issue was with the build itself or whether it was with one of the subjobs attached to the build. So perhaps a smoke test or an AQA test or something like that. This allows us to filter out problems with the build itself and filter out the checks we're doing to it afterwards. We do still triage failed and aborted builds, even if the build itself has not failed. But we don't currently go digging down into the test job to figure out why it's failed. We've been focusing on the output of the build itself. Now, you might be wondering, what does this produce at the other end? What's the reward? And this is the reward. It's a simple list of issues. Here are the latest builds in the pipelines that we identified, and the latest ones that failed or were aborted or had failed or aborted status. And as you can see, under each one, it says what we think the cause was, whether it was preventable, and the line of output that we think caused the failure state. So in this case, we think that the build passed, but the AQA subjob that ran afterwards failed. And there we have a link that you can use. Error exception found, no such file or directory. Down here we have the output size being beyond a certain level. Now, we don't have a line of output here because we don't go interrogating a job's output unless it falls within a certain level of size. We don't want to be searching gigabytes of output. On the basis it would slow the job down to an absolute crawl. And besides, a job output level above 1 megabyte is considered unusual. So we've set a level of 50 megabytes. We've said that if the output is beyond that level, we just don't screen it for regular expressions. And we just skip the regex phase altogether and just say, nope, too much. And in this case, it's something that we already have a fix for. We just need one more approval and we can get the suppression for the various warnings that are causing this excessive output. We can make them go away. And yeah, I think that's pretty much it. We've got a long list of potential ideas for ways we can improve it in the future, but this is the basic script and what it does. I'd like to open the floor now to questions. And specifically, I would like to know if anyone can think of ways that this information could be conveyed to people better. So via a different medium, maybe you'd rather have a summary of this information on Slack. Maybe you'd rather have individuals pinged based on this specialization. I'd like to know what you think about this. So that's everything I've got. Carmen, would you like to take questions, please?